Hi, this is Elina from Visual Components. In this exercise, you will learn to simulate FANUC robots with the FANUC connectivity plugin. Before the exercise, make sure you've installed RoboGuide on your computer and enabled the connectivity plugin for Visual Components. Otherwise, you won't be able to see the connectivity tab. We'll also be using the Post Processor add-on, which you can download on the Visual Components forum. Before we start with the actual exercise, let's take a look at what's in our model. So here, we have a simple machine tending cell. And here we can see the main program of the robot. So first, we have a subprogram that calls for the init function, and after that we have the actual work cycle as a while loop. First in the work cycle, the robot picks parts from the first conveyor and places them in the parametric lathe machine. Then the machine processes the parts. And after that, the robot picks the parts from the machine and places them onto the second conveyor. Let's now open the signal editor to take a look at the signals and connections of our robot. So here you can see the signal network. First, we have the gripper. It is connected to our robot's output ports 101 and 102. With these connections, the robot can both open and close the gripper. The feedback signals from the gripper come to the same ports on the robot's input side. So again, that's ports 101 and 102. Then we have the end block component. The end block acts as a sensor on the first conveyor that brings the part to the robot. That sensor is connected to input port 111 of the robot. And finally, we have the parametric lathe machine. We use the robot output ports 121, 122, and 123 to control the machine doors and the process. We get the feedback signals from the machine to the same ports on the input side. So that means input ports 121, 122, and 123. We can now close the signal editor and run the simulation to see how the robot moves. So, this is the starting point of our exercise. Our goal in this exercise is to verify the FANUC robot program made in Visual Components by post-processing it and running the program in RoboGuide. While we run the program, we'll also be emulating the robot motions in the Visual Components layout. Here, you can see that the robot ends the work cycle and starts a new one. Let's pause and reset the simulation for now, so we can start the actual exercise. First, we'll create the virtual controller. Let's open RoboGuide and add a new cell. We'll rename the cell to FANUC MT so it has the same name as the Visual Components model. Then let's move on to the next page in the wizard. No changes are needed on this page, so we can just click Next. Here, the latest software version is already selected, so no changes are needed on this page either. Let's click Next. Let's select the option to set the EOAT later and click Next. So now we need to select M20ID/25 as the robot model. And then we'll click Next. We don't need to change anything on this page, so we'll just click Next. Again, no changes. Let's click Next. And now on the final page, we'll click Finish. And now RoboGuide creates our virtual controller. While RoboGuide loads our virtual controller, we need to make some selections. So first, we'll set the flange type to option 1 and press Enter. Let's also use option 1 for the dress out type and press Enter. And set the joint 1 motion range to option 1 as well. And again, let's press Enter. Now we just need to wait for the controller to finish loading. This might take a while. Okay, looks like our virtual controller is now ready and we can connect our Visual Components model to the controller. Let's go back to Visual Components to create the connection. On the Connectivity tab, let's select the FANUC Robot option. Then we'll right-click and add a server. Our virtual controller is listed here, so we can select that one and test the connection. And it works! We can close the message and apply the connection. Let's now switch on the server connection. Next, we need to do the variable pairing. Let's start by pairing from server to simulation. We'll right-click Server to Simulation and select Add Variables. So here, on the left, you can see the structure on the simulation side and on the right, the server side. First, we'll connect the joint values. On the server side, under Current Position and Motion Group 1, you can see all the joints of the server. And on the simulation side, we'll select the robot, behaviors, and the robot controller. And now we can see the joints. For each joint, we need to connect the value property. And to see that value for each joint, we'll type value in the search box on top. Then we'll hold down Control and select all of the value properties. Now we need to select all 6 joints on the server side as well. Let's hold down Shift and click the first and last joints. So now we're ready to pair the selected joints. As you can see, the new pairings are added in the list below. Next, we'll connect the signals. Let's erase the text in the search box. And let's also ensure that signal maps are shown so we can view the inputs and outputs for the simulation model. So let's start by pairing the outputs to this server to simulation group. On the server side, under Digital I/O, open Outputs. And on the simulation side, we can see the outputs under the robot name. Now we'll start connecting the signals. We're using output 1 for the grasp and release action. Let's pair output 1 in the simulation to output 1 on the server. To connect the other signals, we need to find the outputs starting from 101. The gripper in the simulation uses outputs 101 and 102, so let's pair those with the same outputs on the server side. Next, we'll find outputs 121, 122, and 123. The parametric lathe machine uses these outputs. Again, let's pair the output ports on the simulation side with those on the server side. So now we're done with the output ports and we'll go on to our input ports. So let's scroll back up. Note that the input ports need to be connected from simulation to server, so we'll need to select that group. And as you can see, the group name for variable pairing updates. Let's open the input lists on both the server side and the simulation side. Then let's scroll down to 101 and 102. Again, gripper signals use the ports 101 and 102, so let's pair those. The sensor is connected to input 111, so let's pair those input ports as well. And finally, the machine feedback signals are connected to ports 121, 122, and 123. Let's do the pairing of those input ports too. Now we've paired all the necessary variables, so we can close this dialog box. We can also show all of the connected variables in a panel on the Connectivity tab. Next, we can post-process the robot program. So let's go to the Program tab, and let's select the robot and launch the post-processor. Next, we need to select the location for our robot program file and name it. Let's name the file main and save it under Downloads. That's done. And in the output panel, we can see that the post-processor created a separate file for each robot subprogram. Now let's go to RoboGuide again and load these subprograms to our virtual controller. In the tree view in RoboGuide, we can see the robot controller and its programs. Let's right-click Programs and then we'll select Load Program to load our subprograms. Let's browse for the Downloads folder, hold down the left mouse button and select all of the ls files our postprocessor created. Then let's click Open. And as you can see, the subprograms were loaded successfully. That means we are ready to test the connection. Let's place Visual Components and RoboGuide side by side to see how this works. In Visual Components, we'll go to the Connectivity tab to view the connected signals. Before we test the connection, we need to disable the Robot Components executor. We do this so the simulation won't run the executor program. Instead, our virtual controller will control the robot. So we'll select the robot and go to its properties. And then on the Executor tab, we'll disable the executor. Let's close and reorganize our panels a bit so we can see better. In RoboGuide, let's open the Teach pendant, and we're ready to run the robot program. In RoboGuide, we need to select the subprogram that the robot program starts with in the simulation, so let's select Main. And now let's run the robot program in both software. First, let's start the simulation in Visual Components and then in RoboGuide. So, you can see the robot is controlled by our virtual controller. We can also view the program in the Teach pendant. So here we can see the subprograms being executed. This is the end of our exercise. You have now learned how you can post-process a program and run it in RoboGuide. Thanks for watching. See you next time.